Example 13.6 is going to give us a look at long division with polynomials. It says here, find each quotient using long division. State the quotient as q of x and the remainder as r of x. So we're going to be using the same division algorithm and the same long division process that we did in example 13.5 with whole numbers. So to help us to be able to keep track of the process, I want to pull up the work that we did from example 13.5. There it is. And we're going to use that as a way to help be able to mirror what we're going to be doing here. So we're going to start with creating a separator. And for my separator, I'm supposed to have the dividend on the inside, which on the whole numbers, that was the 101. And then I need to have the divisor that's going to go in front of that separator, and that was the 3 on our whole number example. So for this example, we're going to see the dividend is x squared plus 8x plus 15, and the divisor is x plus 5. So let me appropriately put those where they belong. And x plus 5 out in front, and that's how we make our setup. Looks identical to what we did with whole numbers. But now I'm going to create a little section in the margin here for scratch work. And I do this because we're going to have to figure out how many times a particular value divides into another value. And we did that over here, but we didn't do it with scratch work because we have a pretty good understanding of how it works with whole numbers. So here's what I'm getting at. The first division that we did was how many times will 1 be divided by 3? In other words, how many times will 3 divide into 1? And the answer was none. It doesn't go into it at all, wholly. So we put 0. So that just means that we didn't take a big enough piece. So let's take 10. So then how many times will 3 divide into 10? Well, 3 divides into 10 3 and 1/3 time. And we take the whole number part of that, and that's what we end up using as the beginning of the quotient. So up here we have that 3, which is representative of the beginning of the quotient. So we don't usually write down that step, again, because we have a lot of familiarity with whole numbers. But with the polynomials, it's really important that we write that step down so we can see how that works. So we're going to take x from the divisor, and we're going to see how many times will that divide into x squared. So how many times will x divide into x squared? It just becomes a matter of simplifying algebraically that division, and x squared divided by x would just be x. So that becomes the first value in our quotient. And I stick it up above the x term in our dividend just as an organizational piece. And so that means that this 3, that was the first part of our quotient, is analogous to the x that we just came up with here. So we're going to be trying to parallel these processes the whole way through. All right, so let's go back to the next step. So after we came up with that in our whole number example, we then went to the multiply step. So let's do a multiply step here. We're going to take x, and we're going to multiply it by the entire divisor. And that's going to give us x squared plus 5x. So the x squared plus 5x is going to be analogous to the 9 that we came up with in our whole number example. And then once we come up with that, we are then expected to subtract. So let's do the subtraction next. I'm going to subtract the entire x squared plus 5x. So that's why I put it in parentheses to remind myself that I'm going to subtract all of it from x squared plus 8x And when I do that, the x squareds are going to cancel. 8x minus 5x is just going to result in 3x. So this 3x would now be analogous to the 1 that we have in that whole number example. After that, the next step was to bring down the next digit. So in this case, we're going to bring down the next term. So we're going to bring down the plus 15. And that completes one round of the long division process with a polynomial. So we got to go through the process again. So on the whole number example, we took 11 and we checked to see how many times will 3 divide into 11. Over here, we need to check to see how many times will x end up dividing into 3x. So 3x plus 15 becomes the new expression that we're wanting to play with. So let me come over here into my scratch work and let me put the expression 3x divided by x. And that would just end up resulting in 3. And that's a positive 3, so we're going to put plus 3 right here next to the x. So that 3 that we just came up with and the quotient would be analogous to the second 3 that we have in the quotient for our whole number example. So I need to multiply again. I'm going to take 3 and multiply it with the x and with the 5, resulting in 3x plus 15. And then that 3x plus 15 would be analogous to this 9 that we have. So we got to go through that subtraction process now. I will subtract all of 3x plus 15, and this is nice enough to where everything ends up subtracting out to be 0, and that represents our remainder. And the x plus 3 up here at the top represents the quotient. So let me write out what the results are that we currently have. So what we currently have is q of x is equal to x plus 3, and r of x is just going to be equal to 0. Now as far as the answer to the division problem, because these are just the pieces that go into the division problem, the answer to the division problem. So we were taking x squared plus 8x plus 15 and dividing it by x plus 5. So the result would be x plus 3 plus 0 divided by the divisor. So I'm using that division algorithm, which is the quotient plus the remainder over the divisor. But when the remainder is just 0, then this second term is all going to become 0. The whole thing just disappears, and so the answer to the division problem is just going to end up being the quotient, x plus 3. And that's what we will box in as the answer to the division problem.